All right. Well, welcome back, everyone. We're going to keep working on this lightsaber some more. I really don't remember where I left off at, so I'll have to figure that out first. But anyways, I'm trying to come up with ways to make this channel more, I guess, accessible to people who want to help and do things, and a way for me to like reward them for doing that. So I think I'll go to the work screen here. Obviously, I'm still got the bounties below here. I think that's still a good idea, but I wish I could do more of them and do easier, more relatable items to the project I'm working on. So I'm going to be trying in the future to come up with a way to display a bunch of bounties at once. Oh, excuse me. And then, and maybe I might diverge into more cryptos than just Dogecoin as payouts too. And yeah, let's see if I can come up with a more organized way for people to help and more accessible to like easier tasks and things like that. Just to try and give people a chance to like start to learn like what it's like to make engineering decisions, I guess, uh, and then see a result from those decisions. All right, let's turn the music back on and figure out where we are. So here's our diagram. I think we did the screen last time. We've done the buttons. I think we were skipping the speakers, so I think the next thing is the Neopixels. Let me just confirm that. Yep, LCD screen is here. Okay, and that's everything for it. So I think that's correct. Sorry, I just got a new circuit maker had an update, so it was running a little slow there. I think it's okay now, but all right. So Neopixels, this will be a thing. I just thought these are going to need a level shifter, aren't they? Yep, and 5 volts. I probably need to be able to turn that on and off. Let's see if I added any requirements for this. Yep, I did. Use PFET, use PFET. Okay. VCC. That's a weird pin name, but blade power, hill power. Okay, so the power to the shoot, what is it? To the Neopixels is going to be controlled, and the two items are going to be controlled separately. The hilt is going to be one power thing. The blade is going to be one other power thing. So that should be fairly straightforward. All right. And then there's also going to be signal lines for these. Here they are. Data in. Okay. And we have to use a level shifter for that. And I'm probably going to use the standard just MOSFET level shifter kind of thing that cheap, whatever, $5 breakout board that you can buy. I'm going to use that circuit. It may not be the best one for this, but it seems to work fairly well, at least for the speeds that I'm going at, so I think it'll be okay. So I guess we got to figure out I guess we need to use a connector for the blade, and then for the hilt, that's going to have to be its own thing. You know, the hilt might have to be its own circuit board. We might have to start another project for that. Yeah, I think I will. Because it's going to have to be near the top, and the way it's mounted and everything, it's going to have to be its own circuit board. And then it's going to have connectors to connect them. So basically, both of these are actually not going to be Neopixels. They're just going to be connectors, and then the associated lines running to power them and turn them on and off. Okay. Let's start with that then. I'm gonna start with the blade, because that might have a connector already built in. So I want to see if that's the case first. And if it is, then we could just use that connector, the mating connector for it on the board. Otherwise, we'll have to come up with our own and splice wires and things. Oh, well, that's kind of dumb. I mean, it kind of makes sense, but... Alright, so... If you notice here, there is a connector. But there is also power lines off to the side. So basically, the... what is that? Oh, it's a ground reference. So the connector just has data and ground, but it doesn't have power. So yeah, we're gonna have to fix that. So we'll have to splice wires and do a connector on that side, which is not great, except we've already done this before. So we already have a connector picked out, I think. That'll work. Man, space is going to be at a premium here, though. Yeah, we'll have to see. Where did we do it at? Was it the power supply? Or was it buttons? I think it was on the button. Yeah, this one. Here it is, this Molex connector. This is what we decided to use. Okay. Well, let's just look this up then. Oops. Don't do that. Yeah, it's this little flat one. This is a 6 position. So we're going to need something smaller. Oh, kind of tired. I might have to go look this up on like supplier website, because they'll have something that'll tell me better. I need a definition for the part number so I know which one to look for. Any similar ones? Nope. Just mating products, whatever else connects to it. What does this data sheet look like? Oh, this could do it. So for Neopixels, we need three circuits. We need a ground, a data, and a power. I think so even though this particular thing right here has 4 wires coming out, it's because 2 of them are ground and are connected together. So you really only need 1 of them. So that's fine. Oh, I forgot about this big capacitor. We're going to have to put that on the board somehow. And whatever line is coming to this is going to have to be a big trace, because it's going to carry a lot of power. Oh, man, whatever... oh, no, that won't be in the level shifter, though. Okay. We should probably double check that actually to make sure these connectors can push that much power, because if it can't, that will be a problem. Max current, 3.5 amps per circuit. That's, I mean, it's pushing it. I think we decided 60 was the number of neopixels we were going to have in the blade. Or something close to that. 60 times 0.06 is 3.6, so just over our spec there. If we exceed that, we could possibly melt the connector. Oh, it depends on the wire size too. It's actually lower for 28 gauge wire. We have to go to 24 gauge wire if we want to use 3.5 amps coming through it. Which, if we buy this thing, should definitely have that. All right, I think that'll be enough. We're going to be really pushing redline there, and I guess if... Shoot, I don't have a solution if it melts. I'll have to think on that. I could see this going really wrong, though. It's got these 2mm pitch option, which is a higher current. That might be better, actually. Like, just in case, go to 24 gauge wire and then do the 2mm pitch. That's a big connector. I guess not that big, though. We could probably fit it. All right, let me get exact part numbers then. So we can use a 1mm pitch, 3 circuit, or that's not even an option. It doesn't even have a 3 circuit. We'd have to use a 4. All right, 1mm pitch, 4 circuit for the hilt Neopixels, because it's a small ring of like 8 of them. So that's not that bad. It's not that much power. And then for the blade, we need to definitely use the 2mm pitch, and we'll use a 3 circuit. And just aim for 24 gauge wire. I really hope I get this right. It's 4 circuits, 5 circuits, 6 circuits. Okay, cool. So we want this one for this is the 2mm pitch, and this is the 1. And we need 4. Oh, it does have a 3 circuit option. Oh, let's do that then. 503, 763. Okay. Definitely need to look at a drawing of this bigger one. You know how thick it is. 2.6 millimeters. Okay, that's not bad. I think I can make this work. It's going to be annoying to have to make all these parts, but I think we can do it. All right. Now let me just hope these are in stock somewhere. All right, let's try this one first. Cool, DigiKey has them in stock. Wow, they're $1.40 each. That's gonna be an expensive part of the design. And then this one. Hey, it's in stock as well. Okay, 77 cents each. All right, I'm definitely going to use them then. Let's go ahead and add them to this list, and then we will add them to the schematic, because we'll probably have to make the parts. Okay. So let's make J11 the smaller one, I guess. And then the bigger one will be J12. Somebody needs to remind me at the end of this to go through and find the, get all the other parts. I guess we did that here, didn't we? Oh, yeah. The connector sockets. Okay, we got to do that too. We'll do that real quick while we're sitting here. That's such a different description than the other one. Okay. This big one doesn't have anything listed with it. I'll have to look that up on Molex's site. I guess this is it here. So let's start with the smaller one then. For use with this housing, 503764. I think that's just the same as the one we already have. 503764. Crimp gold. Oh no, that's not the one that I want. Hold on. Oh, this is the other side of it. 3 circuits. That picture doesn't seem to match. Or maybe it does. Okay, we need the terminals, the 503765. All right. Let me find these first. Hopefully these are in stock. They are. Good. Okay, and then we need to determine the terminal, which is this one. This is 28 to 30 gauge. That's acceptable for this one. Hopefully the other ones will be bigger. It's 5098. So that's the one we already have. So we can just add 3 more to that. So we just have 9. Quantity of 9 instead of 3 or 6. Okay. Now, the bigger one. What does this mate with? 205341. Not super optimistic here. Oh, it is in stock. Look at that. Okay. It looks weird though. Oh, maybe the wires come out this side and it plugs in on that side. But no, that's not right. It looks weird, right? It looks like it only has 2 circuits. It says 3. Maybe the picture's just wrong then. All right. And this should definitely have different terminals. So let's see what those are. 205342. Oh, I don't remember which one we need. We're using this one. So we need a 24 gauge because we need 4 amps. So 24, 20. So that's the bigger one. This is the smaller one. Let's go with the smaller one. This should be enough. So if anyone's confused, these are inside the connector that plugs into it. There's a little metal part that you crimp onto the wire, and then that metal part inserts into the connector, and there's a click and it'll stay. It locks into place. So that's how you get the wire into the connector. And these terminals are the part that does that, so that is why I need them. All right, and we're going to need 3 of these. All right, excellent. So now we can go back here. And now we can go to Circuit Maker and add them. Interesting. All right. So now for the test. Let's go add a part. What are the chances it already has a model? It doesn't. Fine. What about the other one? Any chance? Nope. Knows what they are, but no models. Typical. So we will get started making one. couldn't be that easy. All right, new symbol. Which one is this? 503, 763, 3. This is a smaller one. Okay. All right, so oops. Let's get all these pins figured out. Done. I think I'm just going to go simple on the schematic symbol on this one. There's no reason to complicate it. Not really the best option, but it does work. All right, footprint. New one. Nothing exists yet. All right, this one we'll have to go off the data sheet for. Do I have this pulled up? Maybe. That's the bigger one. Maybe not. All right, don't need that one. Don't need that one. Let me find. That's not what I want. Aha, this one. All right, we want the drawing, and this should tell us the layout. Yep, right here. Okay. It's probably it should be similar enough to the other one. So let's go here and add a pad. And then I need to figure out where they did their 0 on this, but I guess I don't know. I'll just do it from the middle, bottom, I guess. All right. So this is going to be a square one, or rectangular, sorry. One, or, oh shoot. Let's go to metric. I'm not about to do this. All right. So 0.55, and then 1 millimeter tall. Okay. Oh, messed that up still. There's no hole. And then it's not multi-layer, it's top layer. For some reason that defaults every time too, and I mess it up. Okay. That's correct. Now, it's a 3 circuit. How much space between? They're 1 millimeter pitch between circuits. That makes sense. So this one can go in the center. 0, 0. We'll lock that in place. Okay. Now, copy that. Then drop 2 more. 1 there, and 1 there. This one needs to go at 1, 0, and this one needs to go at -1, 0. And then in order, they are 1, this one's number 2, and this one's number 3. Alright, additionally we have 2 ground pads. I'm just going to copy this again actually. And just change it. Alright, ground pad is 1.26 by 1.3. Okay. I need the calculator to learn its dimensions, the way it's measured. Alright, 0.55 divided by 2. Store that's 275. So its x dimension, it's going to be 1, because it's to the reference of this pad right here. So this pad is 1 millimeter over, and then it's actually referenced to the edge of it, so it's half of 0.55 wide, which is this number I just calculated. So 1 plus this, and then it is additionally 1.47 millimeters, so plus 1.47 plus half of whatever the width of that pad is to get the center point, which is 6.63. 0.63 equals 3.375, so that's where that is x. We got close. 3.375, okay? And then its y, its height, is gonna be, so the half the height of the lower pad, so 0.5 plus 1.84 plus half of 1.3, which is 0.65, 2.99. So I missed that one by a little more, 2.99. Okay. Then copy this one. Drop another one over here. Same height, 2.99, and negative 3.375. This is positive 3.375. Yep. Okay. And then as far as the naming goes, ground 0. Well, ground 1 maybe. Ground 2. Okay. That's easy enough. Oh, we need to add ground pins to the symbol, because otherwise it won't. And I hate that we have to do this, but I haven't figured out a better solution yet. Just drop this a little wider. There we go. All right. Ground 1. Okay. Ground 2. Okay. All right, we'll save that. Save this. It's not done yet though. Okay, I'm gonna actually use Alright, I need this connector. This one. 3763. I'm going to download a 3D model, and that'll hopefully help me out here. There we go, step file. Let's extract this. Glad Molex is nice enough to do this, you know? Like, it makes it way easier. Alright. 3D, no, all objects. We want a 3D body from, I don't know. I'm just going to draw it out real quick, knowing that our download should fix it. Come on. There it is. Let's do generic. Path. Downloads. Open this one. And I'm going to make it black. Well, we'll start with gray. I'll change it to black once I position it correctly, because typically these things don't position right. So if I go to the 3D view, oof. You know what I might have missed before? I think they might position it to the first pin and to the center. Interesting. That's really interesting. Okay. All right, so if we go back to this, all right, location 1. Okay. And then as far as its extrusion height, standoff height, there it is. Half the thickness of the part, which is 1.5 millimeter. So 0.75 standoff. All right, if I do that, what do we end up with? Almost. It's not quite. I wonder if it's to the top edge of the pad and it needs to move down 0.55. Shoot, math. .905 minus 0.55. 1.355. That might be too much. Yep. I think I had this problem last time too. Let's just go with 1.8. See what that gets us. I ended up just eyeballing it. Yeah, that's about right. It'll settle in anyway when it gets soldered on. Alright, cool. Looks good. Alright, one last thing. We're going to make this black. I hate how it colors the pins like that, but the whole thing is black, so, you know, it seems to make sense. Alright, so that part's done. So we can save that. Now we got to make the other one. Alright, yep. Save to the server. Let's see if it works. If it does, we'll be good to go. Yep, looks like it's gonna. Caused a little bit of lag there when I uploaded this. All right, cool. And that means now I should be able to place it. Good luck finding it. All right. Which one is it again? J11 5036 503763 -0391. This one. Why is there two of them? Oh, that's the 0691. That's the bigger of the two. All right, so this is the hilt, so I'm going to put it up here, and I'm going to do the blade lower down. Just drop it right here. All right, excellent. And then we will name this one J11. All right, save this real quick. Actually, wait, let's not. All right, let's do the other one. I wonder if I could just use the existing symbol from the one I just created, actually. Oh well, I'm already committed. I don't know why they all start off default saying vhost. 270 degrees, okay. Ground 2. Oops. All right. And then I should double check, but I think it goes left or right to left. So let me pull this up. Drawing. Yep. So we're going to go 1, 2, and 3. All right, that looks good. New footprint. All right, here's our footprint for this one. Quite a bit bigger, it looks like. So let's start with our usual pad. Oh no, this one's also in Imperial. Let's go to metric. All right, it is how wide? 1.1 wide. That's right, because these are 2mm pitch. And 1.45. All right. And then, yeah, 2mm pitch, so this will be at -2 and 0. And this will be at 2 and 0. Something's wrong. -2 and 0. This didn't get fixed. Okay. 2. There we go. All right, and this will be 1, 2, 3. All right, and now we need the ground pad. All right, so its width is 1.35. Height is 2.9. It's sizable. Okay, then as far as positioning goes, it's going to be 2 plus 0.55 plus 1.67 plus whatever half of 1.35 is, so 6.675. $4.895 on the X. And then as far as the Y goes, so half of 1.45, so 0.725 plus 3.8 plus half of 2.9, so 1. Is it 1.95? No. 1.45. Got there in the end. 5.975. Got really close, actually. Okay. All right. And then we'll copy that. Put one on the other side. And do opposite numbers. So -4.895 and 5.975. So -4.895, positive 5.975. And this will be ground 1 and ground 2. Excellent. All right, now I guess we need to download the CAD model again. All right, and then we'll import it. We'll do a 3D body. Oops. This one. Looks like it's a little off. We'll figure it out here in a sec, though. I need to override the color because I can't see it. All right, close, but not really. Definitely needs to go up and then needs to slide forward some. All right, what is the thickness of this? 2.6, it needs to go up 1.3. So standoff is 1.3. Okay. All right, that puts us at the right height. Whoops. And then it needs to slide forward like a bunch. An additional 1.45 maybe. Additional 1.5. 0.5, so 4.3. 5.3. Let's try that. Whoa. Is there a way to reset it to views? Yes. Interesting. Oh, okay. I see what's going on here. Oops. I'm just learning the keyboard controls for this. Sorry. All right, I think that works. So save that. Save this. And save it to the server. Hopefully everything matches up. Looks good. All right, and we'll add it in as J12. 205338. This one. We'll drop it down here. All right, cool. So those are our connectors for our Neopixels. Let me name this J12. So now we need a level shifter kind of circuit. Let me go see if I can find that one that I bought before. I might have more of them. I don't remember if they came in a pack or not. Hold on a sec. Oh, I might have thrown them in a box somewhere. So if I still have them, I can figure it out with the SD card readers. I could have sworn whatever I bought I had multiple of, but maybe not. Oh, here we go. Yep. All right, I'm just going to open this. So I'm not going to actually use this part. I just want to look at it and see how the circuit works so that I can use it on the, I can just design a similar circuit. Does it have a part number on it? It does not. Interesting. But it's a tiny little thing. It works. They worked on the Falcon fairly well for the Neopixels, so I think they'll be okay here. I know that, so looking at, let's see, this part on Adafruit's website, that it's designed as an I2C converter, and really that's pretty much what it's best for. It's not designed for an SPI or for UART or WS2812 or anything like that. It just happens to be really good for this particular thing. Oh, at least they... Okay, so they talk about what part they use, though, so that's good. 138 FETs with 10K pull-ups. Works down to 1.8 volts on the low side, 10 volts on the high side. 10Ks do make the interface a little more sluggish than using... so we suggest checking this out if you need a high-speed transfer. Okay. While we design it for use with I2C, this works well for TTL serial, slow SPI, and either digital interface, both unidirectional and bidirectional. So that's a fast enough interface for WS2812, because that's 800 kilohertz. So as long as it's under 2 megahertz, it should be fine. So I wonder if there's WS2812 specific level shifter. Let's see. All right, it seems like people seem to prefer the 74 HCT 245 or the 74 LVC 245. Wonder what the difference between those is. Let's see here. Protocol friendly 8-bit logic level shifter. Be an easy enough part to place. Maybe I could find something smaller though. This chip is only for digital signals, and for analog signals you can opt in for that. It has 8 pipes it can convert, but it won't work bidirectional pull-up based devices such as I2C or one wire. It does work great for SPI, serial, parallel bus, and other logic interfaces. I really don't want an octal. I'd rather have... Okay, let's see if we can find one then. So going back to DigiKey, although, well, I do need 2 though, so maybe I can find a chip with 2 circuits. Let's do level shifter, see what comes up. Translators and level shifters. All right, in stock. Active. Just one direction, 2 circuits. Let's just see what Texas Instruments offers in this category. I want tube or cut tape. Boy, they were not taking me seriously when I said 2 circuits, didn't they? Oh, channels per circuit. Oh. All right, let's take out the number of circuits and go back to maybe like 1 circuit. Channels per circuit, 2. Is that what I want? I have no idea. IC translator bidirectional. Anything come in a dip package? Nope. Just SOIC for something this small. Let's see what we got. SN65 level T22. Let's see how this works. D0 and D1 are the TTL inputs. Maxed input is 6. I don't think that's what I want. It's shifting down. Okay. Maybe I'm not looking for the right thing then. Yeah, it seems to be doing the same thing. Alright, maybe we just go with the tried and true method then. BSS 138. Let's see what we got. Imagine there's a few. Let's look at what arrays they got. As much as I want to, that would be really hard to solder. Oh, none of these are in stock too. Alright, well let's find one that in stock, active, cut tape. What we got? Let's find one that already exists in Circuit Maker. We just need 2 of them. Oh, I forgot. We gotta control the power on and off as well. That's gonna be trickier. We'll deal with that in a sec. All right, how about this one from On Semiconductor? Oh, all parts. Surely it's got a model. Yep, looks like it does. Okay. That's Diodes Incorporated, actually. Oh, excuse me. This one does not have a model. But the Diodes Incorporated one does. Are they here? have the 138Q. I imagine they all work very similarly. That one doesn't have a model either. $38. I mean, honestly, they should all have the same footprint, more or less, so, because they're all SOT23s, so whatever one I pick should be fine. I just wish I could find one that's in stock. That's 138 PW. This one is. And it's fairly cheap. All right, let's do this one. Never used their stuff before, but we'll see what happens. What could go wrong? All right, one there, one there. Cool. And then I'll wire it up in a sec. First, I need to add it to the bill of materials. What did we say that was? Q8, Q9. All right. And now to double check. Same thing they're using here, so they probably have their circuit here somewhere. They just have 10K pull-ups on each side, right? 1, 2, 3, 4, 5, 6, 7, 8. Yep. Eagle files on GitHub. Do they have possibly, they have schematic and board in Eagle. They don't have the actual circuit just drawn out. That's really disappointing. What is this? Oh, just the image. Oh, well, this could probably tell us the circuit, though. Looks like the whole thing's done in almost a single layer, so. Almost. Okay, so where's the gate? Gate is pin 1, which should be this one. Which appears in all cases. Let's see. It's connected to the low voltage. So 3.3 volts. Yep. Okay, so the gate is always connected to 3 volts. So let's do that first. And what do we call that in the power supply here? Or do we? Maybe in the teensy then. 3v3, okay. All right, and then we need to figure out which one's connected to the high voltage side and which one's on the low side. So looking back at this, all right, so pin 1, this one is the gate. Pin 2, this one is the source, and then the drain is over here. So the source is always connected to the low voltage. And the drain, I assume, yeah, is always connected to the high voltage side. And both of them are using 10K pull-ups to their respective voltages. That makes sense. So source is the lower voltage. Okay. So pin 2, the source is the lower voltage. And then this is the higher. I think I'm just going to use pin 2 as the data line on all of them. Move this up here. All right. I'll use pin 3 as the ground. Let me go ahead and drop some power reports here. That was kind of a confusing way to do it. Yeah, I'm going to delete that. All right, there we go. And then finally we have our power lines. Oh, and these need to be connected. Okay, so we've used a 10K resistor before, right? Yes. 10K for R5 and R6. Give me that part number. And we are going to add it in here, because we need them on both sides. We need 4 of them. 1, 2, 3, 4. So R16 through R19 is now added. And I'm going to probably have to reorganize this some. Yeah. I like to have my pull, like the power, pull up things on top and then grounds on the bottom. That's what's making this weird, because if it has it on top, then this line coming out needs to go to something else, and that's kind of odd. Though maybe not. All right, let's go through all of these and turn the name off and then rotate them. 90. Okay. Oops. There we go. And drop these ones in place. That might be a little close on that one. Go. There we go. All right. And now this side needs to be pulled up to 5 volts. And then we need to connect this one down here as well. Let me go to my pin out here. So this is the data. Hilt neopixel, blade neopixel. So hilt is the smaller one. I have to bring this out. Long name. Hilt neopixel. And blade neopixel. Okay, and then we should probably go label those in the teensy so we have them. Which is which? So blade is on pin 20. It's over here. And what's the other one on? Hilt is on 21. All right. Making good progress. All right, back to this. Now we need to be able to turn the power on and off. So I'm going to need... Should use a P-FET or an N-FET? Probably a P-FET in this scenario. MOSFET, P-type. And this is going to be a lot, actually. In stock, active, P channel. The voltage limit's going to be fine. Tube, tray, bag, bulk, I don't know. Strip. I'll take just about anything. I think what's going to hurt us here is that our current has to be kind of high. I might need to do multiple if it's really high current, because we're talking like almost 4 amps, like just to be safe. Oh, man. Let's just try all these 4 amp ones, see what we get. Oh, wow. Some of these are really beefy. I honestly don't know if it better. It might be good to just use something like sizable like this. I'm scared to trust something like this that says 4 amp, but is this tiny? Although I kind of want to pick one that's already in Circuit Maker too, because I really don't want to make this part. So drain. Power management switches. Well, it's for the thing I need it for. Gate threshold voltage. I think this could work. So that's the gate. Two. Source 3 is drain. That's the drain up high. Well, I wonder if it exists. Nope. Alright, I'm going to start rolling through these and seeing what I can find that already exists. Alright, here we go. I don't want to use one of these giant D-pack things, but it might be the easiest to solder and pretty solid. Oh, where'd it go? There it is. It's from Vishay. It's not something that needs a fast switching time, so I don't have to worry about that. Oh, wow, that does have a... Oh, man. It says 2.8 amp here. It says 4 amp on this. Let's see what the datasheet says. At standard temperatures, it's 4 amps. At really hot temperatures, at close to boiling, it's higher. All right, I think we'll use it. Just got to figure out the pin out. Oh, what's the gate threshold? All right, I think it's fine. All right, yeah, I think this will work. I just like how ridiculous it is. How to do this best. Maybe like right there, and then right here. So I believe the way this works, we want to go... This is the signal line, obviously. Let's draw those out. Five volts goes in there, and then out this side we want to go into the input. What's the voltage loss at high current? Interesting. I'm definitely going to need somebody who maybe knows what they're doing a little better than me to check over this when I'm done. Because I clearly don't understand very well. Just to make sure I get this right. Alright, as far as I can tell, this is correct. This 5 volts needs to go in at pin 2, and then the output goes into the power for the Neopixels. And then we just need to just add our control lines there and add this to our bill of materials. So what do we want to name what do we name those signals? Blade power and hilt power. So we'll name this one hilt power. And that one blade power. Okay. And then we need to name them over on the TNC schematic as well. What are they connected to? Pins 32 and 33. Oh, either side. Okay. So 32 and 33. Which is which? .32 is blade power. .33 is hilt power. Okay. I don't know if we need like pull-ups or debounce capacitors or whatnot on any of these. It might not be a bad idea in some scenarios. So we'll just have to see. I'll leave that open. Obviously we have pull-up resistors for the level shifter. And I gotta make sure all this stuff is on the bill of materials. So QA and Q9 are already there, but Q10 and Q11 are a different part. How expensive is this part that I just picked out? That's probably something I should have checked sooner. Or double checked. Whoa! No, don't share. Do I have it pulled up? $2 each. Wow, they're expensive. Alright, so we said Q11 through 12. Don't have a value for that. This is going to take up a lot of space. All right, excellent. Now, I think that's everything I wanted to do here, and it's added to the bill of materials, so let's try and validate everything. Make sure there's no errors. Okay, looks good, and then let's update the PCB document, because I just want to see what this stuff looks like. All these extra components. Validate changes. I still don't understand why I get errors on some of these. Execute changes. And then pull up the board. All right, and look at all of these random new parts. Oh, man. The models don't... Hold on a second. All right, let's slide this out and put this over here. Oh, there's a minimum height. Okay. Put this over here. Put this over here. Slide that down. Don't know what this thing's deal is. See, here's Q9. Let's drop that over here somewhere. Let's move this up. Oh, it has a resistor under it. That's why it's freaking out. Just keep moving stuff around until I'm no longer getting overlapping errors. All right, where did everything go? We have Q9, Q6, Q7, Q5. I feel like we're missing something. Where's Q8, Q10, Q11? Oh, here's Q8. Oh, Q10 and Q11 are these big ones. Okay, cool. So now if I go to 3D view, see what's disappointing me is that these giant ones don't actually have models. They just have the footprints. So that's kind of disappointing, but everything else does. So that's cool. All these MOSFETs and everything. This looks good. This looks really good. I kind of want to add this now to the screen so I have a way to power the screen on and off. I think when I'm done, I'll have to decide on that. I don't have a lot of I/O left. If we go look at the pinout here. Oh, yeah. I have a single line left for extra I/O. So if I decide to add something, I have to be ready to deal with... Yeah, okay. Oh, we haven't used our I2C lines for anything. So that's an option as well. Those are unused. And it's looking like we're probably not going to. So, okay, so I have 5 lines. So yeah, I can add stuff later. I'm having a hard time figuring out how I'm going to fit all of this on a circuit board that, you know, is really tiny, but we'll figure that out as we go too. All right, good work so far. Let's push everything to the server. Just get everything backed up and then move on to the next thing, which I guess would be the accelerometers. That's going to be its own thing. Okay. I don't know if we can get to wiring them up here tonight, but we might be able to at least create a part or something. Those are going to be sizable too. Man, this is getting insane. It's going to be tough to pack all this stuff in. I'm going to have to do a 4-layer board at least. I might have to do more than that. All right, back to it. I cannot wait to have to do this massive layout. Especially around the teensy. Alright, where are we putting these? Here. So, All right, the accelerometers are their own little boards, kind of like the Teensy, so they don't really have... shoot, where is it? Here. Okay, these, the Adafruit 2809s. So there's almost definitely not a model for the part, but I wonder if the part even exists. Because that alone, I think, would be impressive. I don't think it does. I think I'm going to have to make this whole thing. Oh, wow. It does. Why didn't I use it? It must have something to do with the model or something? The fact that it exists is already incredible to me. Yeah, let me place this. 1, 2, okay. Is there any way I can look at a model? All this has to be connected up. Yeah. All right. Let's just save that. Errors everywhere. That's fine. Validate. So many things messed up with them. Oh, duplicate designators. What do we call these if they're just boards? I guess U is the best. We're at U4. Let's go to U5 and U6. Why do they have this little symbol next to them? Oh, okay, that goes away when I do that. All right, cool. So let me go to update PCB document. I just want to see what it looks like. Validate, errors everywhere. Execute. Oh, that's kind of weird. There they are. Oh, they don't have the mounting points on them. That's why. They're all mounted on one side. I can use the footprint, but I need to modify it. There was a way I figured out how to do that. Okay, that makes sense. Just drop this out here, drop this out here. Just want to see what they look like so far. If there's a model for them. Kind of. Not really. I might need to fix that too. I could just do basic shapes to get there, but yeah, I gotta fix that. Okay. But this does mean that I think I can use the symbol at least, if nothing else. Alright, let's update this to the PCB, remove those. Why did those show up now as weird and not being executed? Oh, I had this issue before. There was something really weird going on. Oh, I didn't realize that. We need to fix that. Okay. That's right. There was something super weird about that. Okay. Let's just go ahead and ban. All right. I'm trying to decide what to do now. I think this getting fixed would honestly be more important right now, but I don't know how manageable it is in the... I'm getting tired, so I can't keep going, but I'll start making more mistakes if I do. Let's see what we can do here. Let's go part. Oops. No, stop. Part. And then this. Edit. Let's see what this gives me, if it ever stops freezing. Okay, here we go. Why doesn't it have a footprint? Existing. Oh, okay. It does. It has this one, which is the one I want to edit. All right. Okay, all of these are named 1 for some reason, which is a horrible naming scheme. 17, 18, 19, 20, 21 probably. I wonder whoever made this, what they did with it, because it wouldn't have worked this way. All right, I'm going to need this data sheet open as well so I can figure all this out. All right, this looks like it may not be too bad, which is good. All right, 18 is a blue, green, red anode. Is that what they're named here? Or A? I probably need to name them actually according to this. So this is A. Okay. KB. G. And KR. Okay, I think that works actually. So if I save that to the server. Oh, good. Errors. component, hold on. Duplicate pad designator on pad free 1. What pads are named free 1? Is it these? Or this one? Free 1. Oh, it is. Why does it keep telling me that its designator is just 1, even though it's free 1? I guess we'll name them just around G1. G2. G3. G4. Let's try that. All right, looks good. All right, so now the issue is how do I validate this and update it? If I validate the project, does it come up? Nah, it doesn't work still. Unknown pin DS1-A, DS1K. Why? What if I delete it and replace it? All right. Let's add a part. This one. Place. We're going to drop it right there. Everything's going to connect up beautifully. Validate, update PCB document. What? Ah, still unknown. All right, let's execute the changes, see what happens. Still there, but everything's still named wrong. Okay. Let's go here again. I wonder if those changes even saved. Edit. They did not. Or maybe it did to my, hold on. If I go to favorites, what do I get? Does it exist here? This one. So did it make a custom one for me? All right, do we have a second one? We do. How does this look? Okay, it's got the right naming scheme now. Kind of. All right. So let's go back to LCD screen. Delete this one. Drop this one in its place. Rename it to DS1. Validate that. Update the PCB document. Validate changes. We're getting closer. The A worked, but these ones didn't. Yeah, they didn't connect. Dang it. Ah, oh, so close. Something's still off. KB, KG, A, KR. What am I missing? The proof is in here somewhere. What was the error? Update PCB document. Okay, validate the changes. It doesn't seem to have the closed parentheses. To net DS1. All right, what are they? Unknown pin, DS1, KB. Interesting. Hold on. Let's try something. Eventually I'll get there. Oh, that's interesting how you notate that. Okay. It doesn't like that close parentheses on the designator. I wonder if that's a special character or something. I'm just going to do it without. KR, KG, and KB. All right, save that. And then on the this, KR, KG, KB, or other way, KB, KG, KR, and A. So this is KB. KG. KR. And anode. And then we had to set these as well. To G1. G2. G3. G4. All right, so save that. Now here, this should be changed. Save that. Save it to the server. Any errors? Should be good. Okay. Then our LCD screen dock. Let's delete this. Validate. Does anything change? Nope. Okay, so let's get rid of that. And then part. And display. Is there any others? Just this one? Okay. That still doesn't look right though, because look, the pins are still messed up. Okay, we got 2. This is the new one. All right, let's place this one. All right. Name this DS1. All right, validate. Update PCB document. Any changes? Execute changes. Close that. I think it worked. Nice. Okay. That was a lot of effort to get there, but we fixed it. All right, we fixed the LCD screen. Sweet. And it still looks good. I can't get over how good that model looks. Oh, that model's still wrong. It's too high or too low. It needs to sit up higher. Like a lot higher. Oh, we gotta modify it again. All right, I've been going for over 2 hours now, and my brain is tired. So I'm gonna work on this more next time. But at least now I know. Okay, I got to do that, and then the accelerometers. We have to do that too. We're getting there. We're getting close. We're getting to the really tricky stuff now. All right, let me save this to the server. Well, thank you all for joining me tonight. There was a lot going on there, but we got a lot done, and it's getting so close. Hopefully next time we will finish this LCD screen thing, finish modifying the part to make it work. We did the Neopixels, so then we'll do the accelerometers, and then we just have the motor and the speaker left, both the 2 circuits that are the most foreign to me, so we will try that. All right, it all looks good. All right, thank you all for watching tonight. I will see you on Thursday.